Monday, June 1, 2026. Carbon dioxide highest in millions of years, update 2. The above image shows IPCC projections for CO2 concentration and temperature change for the SSP5-8.5 scenario. The IPCC translates concentrations of greenhouse gases into radiative forcing, see image below, which can in turn be converted into temperature change, see image above, by using a climate sensitivity multiplier. In the SSP5-8.5 scenario, radiative forcing is by definition projected to increase to 8.5 W/m superscript 2 by 2100. When using an older climate sensitivity multiplier of 0.75, this could result in a temperature rise of more than 6 degrees Celsius by 2100. Recent research such as by James Hansen et al. Suggests that a higher climate sensitivity multiplier should be used, which could result in a temperature rise of more than 10 degrees Celsius by 2100 in the SSP5-8.5 scenario. The IPCC has a history of trying to downplay the strength of global warming and refuses to accept that its projections have been too low. Lo and behold, some scientists have now come forward to accommodate the IPCC by suggesting to drop SSP5-8.5 altogether, arguing it had become implausible, based on trends in the costs of renewables, the emergence of climate policy and recent emission trends. Let's take a look into those arguments. While the cost of renewables and sales of coal have fallen, the emergence of climate policy depends on political opinion. The temperature rise is accelerating and feedbacks are threatening to kick in with greater ferocity. The rise in the Earth energy imbalance and in ocean heat is outpacing SPSS5-8.5, as discussed in an earlier post. Furthermore, the aerosol masking effect is decreasing. Additionally, IPCC models subtract assumed carbon dioxide removal, CDR, despite doubts regarding the way the IPCC seeks CDR to take place, as discussed in this post and in this video posted on Facebook. Therefore, it is vital to include SSP5-8.5 as a reference, in order to inform and warn about a potentially huge temperature rise, the more so since mainstream media fail to do so and policymakers typically look only a few years ahead. Indeed, not including warnings could be a recipe for bad climate policy, halting or even reversing the necessary climate action. Now let's take another look into some recent measurements of greenhouse gas concentrations. The image below, from an earlier post, shows the CO2 concentration over 31 days at Mauna Loa, Hawaii. The hand points at a daily CO2 concentration of 433.95 parts per million, ppm, recorded on May 1, 2026. The image below, dated June 1, 2026, shows carbon dioxide concentration over the past few years at Mauna Loa, Hawaii. Note the high surface flask measurements recorded recently. The image below shows daily carbon dioxide at Utqiagvik, formerly known as Barrow, Alaska, June 1, 2026. The image below shows nitrous oxide concentration at Mauna Loa, Hawaii, June 1, 2026. The image below shows monthly nitrous oxide at Utqiagvik, formerly known as Barrow, Alaska, June 1, 2026. Nitrous oxide has a lifetime of 109 years and a global warming potential, GWP, of 273 for a horizon of 20 years and also a GWP of 273 over 100 years, according to IPCC AR6. Nitrous oxide is both a potent greenhouse gas and a compound that depletes ozone in the ozone layer. The image below shows the globally averaged marine surface mean nitrous oxide concentration through 2025 with a trend added to show the potential for a huge rise by 2047. The image below shows monthly methane at Mauna Loa, Hawaii, June 1, 2026. From earlier post, discussed on Facebook. Greenhouse gas concentrations are rising and carbon dioxide and nitrous oxide are rising fast, while methane is rising even faster, see image on the right, and more methane threatens to erupt from the seafloor, as discussed in earlier posts such as this one and this one. There are many feedbacks that further contribute to the temperature rise, such as albedo loss and more heat moving remaining in the atmosphere instead of being absorbed by oceans, ice, and land, as discussed below. Altogether, this could result in a temperature rise of more than 20 degrees Celsius within 1 year, as discussed in an earlier post. The image below shows a worrying recent rise in concentrations of sulfur hexafluoride, SF6, which has a global warming potential, GWP, over 100 years of 24,300 and, because it has a lifetime of 1,000 years, its GWP over 500 years is even higher, i.e. 29,000, IPCC-AR6. Regarding SF6, one does not have to bother to check historical levels, since the vast majority of SF6 in the atmosphere is produced by people. It's a synthetic, industrial gas that leaked from its use mainly as an insulator in high voltage and medium voltage power systems and lines that can carry power over long distances. Clearly, too little is done politically to reduce SF6 emissions, even though there are safe, viable alternatives available to using SF6 in the power industry. Furthermore, rooftop solar systems can, where needed, be part of microgrids, which can reduce the need for transmission lines, poles, and towers, so microgrids can also reduce fire hazards. Fire can also destroy warehouses where SF6 is stored in tanks. For high concentrations of sulfur hexafluoride recorded at other locations, also see this post and comments at Facebook. The image below shows global annual mean SF6 through 2025, with a trend added to show the potential for a huge rise by 2037. This is an update of an earlier post that also discusses the Earth energy imbalance and the threat of a rapid rise in methane in more detail. Conclusion: the situation is dire and unacceptably dangerous, and the precautionary principle necessitates rapid, comprehensive, and effective action to reduce the damage and to improve the outlook, where needed in combination with a climate emergency declaration, as described in posts such as in this 2022 post and this 2025 post, and as discussed in the Climate Plan Group. Links: NOAA, Global Monitoring Laboratory, Data Viewer hub//gml.noaa.gov/dv/yadv. NOAA,